Have you noticed? The weather has stopped behaving the way we are used to. Sudden heat waves, unseasonable hurricanes, a shift in all climate rhythms. All of this has already become a part of our reality. People observe the changes and feel them firsthand. Yet there is practically no comprehensive analysis in the media of what is actually happening. We get scattered news reports, but no one is putting them together to show the big picture. We used to be able to predict what the weather would be like in 1 month or 6 months. Now, everything is changing so rapidly that we cannot keep up. What will tomorrow look like? What awaits us in 1 year or in 5 years? Only one thing is clear: the climate has lost its predictability. Today, we will try to bring together all the available information, understand what gets left out of official reports, and figure out what we truly need to be prepared for. The disconnect between what people experience and what they are told has existed for a long time. Over the last few years, this gap has become so obvious that it is impossible to ignore. People see the changes with their own eyes. Winter does not show up on time. Droughts appear where they have never been seen before. Downpours hit right in the middle of summer. And there are more and more examples like this. Scattered observations by themselves do not form a complete picture. To see it, you need to regularly analyze the data and understand how events in different regions of the planet are interconnected. This is exactly the element that is most often missing in public discussions about the climate. One of the most obvious signs of these changes is the shifting of the seasons. Scientists note that spring in the Northern Hemisphere arrives earlier than it did several decades ago, and fall seems like it just does not want to end. Plants and animals are the first to respond to these shifts, making it incredibly noticeable. Plants start blooming out of season. Birds change their migration times. Rhythms that took thousands of years to form are starting to break down. Different species adapt at different speeds, creating a mismatch, where insects appear when flowers have not yet bloomed, or when they have already finished blooming. All of this happens gradually, year after year, going almost unnoticed by the average person. Individual anomalies catch the eye right away, but the big picture only becomes clear after many years of observation. The atmosphere, the ocean, and the land are constantly exchanging heat and moisture as part of a single, unified system. The key element of this system is the ocean. It absorbs roughly 90% of the excess heat that is built up due to the greenhouse effect. Without this buffer, the atmosphere would heat up much faster. But this absorption does not come without consequences for the ocean itself. The accumulated heat transforms the water itself, causing it to lose density, change its flow patterns, and gradually release that heat back into the atmosphere through evaporation. The impact of this process is stretched out over time, showing up in weather conditions months and even years after the heat was initially absorbed. In 2023, ocean water temperatures reached a historic maximum for the entire period of recorded data. Record-breaking values were registered in all oceans at the exact same time, and they persisted for many months, something that had never been seen before. This event was the direct result of a lengthy process of heat accumulation. The reason lies in the physical properties of water. Because it takes approximately 4 times more energy to raise the temperature of 1 kilogram of water by 1 degree than it does for an equal mass of air. This principle works in the opposite direction too. Water releases accumulated energy much more slowly than it absorbs it. Air masses can cool down in just a few days, while the surface layer of the ocean holds on to heat for weeks and months. Researchers consider the ocean to be a slow component of the climate system, since the way it heats up and cools down takes a long time, extending the effects of a hot spell way beyond its actual time frame. A warmed ocean gives off energy, and the atmosphere right above it reacts very quickly, sometimes in just a matter of hours. As surface water temperatures rise, evaporation picks up, and having more water vapor around leads to a massive release of energy when it condenses in the atmosphere. Tropical cyclones get an extra boost of energy right as they move along their path. During the summer of 2023, abnormally high temperatures in the Atlantic fueled hurricanes to massive power, leading to prolonged storms, intense rainfall, and serious destruction along the coast. A similar mechanism kicks in when heavy rains form over land, since an overheated ocean produces more evaporation, and air currents carry this moisture over huge distances deep inland. This exact same pattern plays out on a continental scale too, but there it shapes the overall climate conditions for an entire season. The North Atlantic dictates pretty much all the climate conditions for Europe, including how much moisture is in the air, the paths and strength of the winds, mild winters, and cool summers. Western air masses travel over warm water, soak up moisture and heat, and deliver all of it to the European continent all year round. That is exactly why London and Paris are noticeably warmer in the winter than cities at similar latitudes in Asia or North America. The flip side of this reliance is that Europe is incredibly sensitive to any shifts in Atlantic surface temperatures compared to the historical averages. The North Atlantic acts like a switch that dictates what kind of summer and winter Europe will have. Whenever its surface temperatures climb higher than usual, the atmospheric patterns over Europe shift, and the weather we are used to starts playing out in a completely different way. During the summer of 2023, this connection showed up stronger than ever before. Surface temperatures in the North Atlantic hit record highs for the entire history of weather tracking, and experts describe the situation as completely unprecedented in both its scale and how fast it developed. According to early studies, the ocean basically went through decades of warming in just a single summer season. This was a very specific Atlantic event with clear timeframes and geographical boundaries, rather than just another part of the ongoing global warming trend. There is no clear direct link to the El Niño pattern in the Pacific Ocean, although some experts think there might be an indirect connection between the two processes. This phenomenon is known as a marine heat wave, which happens when sea surface temperatures stay significantly higher than normal for several weeks at a time. This exact anomaly created a highly unusual temperature pattern over the Atlantic and heavily impacted the European summer, leaving a lasting impression on many people. Researchers had to piece together the mechanism of how the warm Atlantic influenced the atmosphere over Europe step by step, gathering information bit by bit. Certain aspects still spark scientific debate today. As ocean surface temperatures rise, moisture evaporation into the atmosphere increases, leading to a shift in cloud cover over the surrounding areas. And data from various weather stations during that specific period backs this up. Based on available data, the shift in cloud cover could have affected the amount of solar radiation reaching the ocean surface and the nearby land. A decrease in cloud cover leads to an increase in direct sunlight, and this could have caused additional heating of the air masses moving toward Europe. The warm Atlantic acted as a background amplifier that drove up air temperatures over Western Europe. But it was not the only factor behind the heat that summer. The marine heat wave alone cannot explain the entire situation, but the overall picture would have looked completely different without it. The moment the atmosphere and the ocean began to feed off each other, Europe faced a phenomenon that people used to see as a rare exception to the rule. Heat waves that previously only happened once every few decades suddenly began to occur with a frequency nobody had ever seen before. The summer of 2023 went down as one of the most sweltering on record for the European continent. A blocking high-pressure system settled over Europe, acting like a tight lid on a hot skillet, and the hot air masses stayed put for many weeks. The summer season of 2024 brought no relief and also turned out to be extremely hot for European latitudes. 2 record-breaking, sweltering summers back-to-back prompted the scientific community to seriously consider whether this kind of heat has become the new climate normal for the European continent. Why exactly is Europe experiencing such changes? This continent is heating up roughly 2 times faster compared to the global average. And this phenomenon cannot be chalked up to a simple coincidence or a measurement error. One of the key reasons is tied to the specific behavior of atmospheric processes over this region in recent years. Blocking areas of high pressure occasionally form over European territory, and in some years they stay completely still for an especially long time, keeping out any clouds or cool air currents from northern latitudes for weeks on end. While the high-pressure system stays put, the ground underneath it loses moisture and dries out, and the air masses right above the surface heat up even more intensely. The more parched the surface of the Earth is, the hotter the layers of air above it get. The more stable the high-pressure system itself becomes, and the whole mechanism feeds on itself in a vicious cycle. A unique situation unfolds in the Mediterranean region, where hot and dry air currents from African deserts sweep in from the south, and the sea itself absorbs and holds onto thermal energy. This specific area is exactly where record-high temperatures hit the most often because of a mix of dry African air and overheated ocean waters. Scientists have ways to calculate the exact odds of a specific heat wave happening without climate change caused by humans, and the results usually turn out to be exactly the same. Without human influence, these kinds of heat waves would be way less intense or practically impossible. As all these factors pile up with each passing year, the next freak weather event becomes a little more likely to happen. And it gets harder and harder for experts to just brush off individual cases as a simple coincidence. The Mediterranean region is dealing with some especially brutal conditions, since the climate out there is already dry to begin with, and the ongoing changes are stretching out the dry spells and cranking up the heat while they last. The warmed-up ocean does not bring rain to the places that actually need it, but it definitely makes the scorching heat over the mainland even worse. The soil and plants dry out a whole lot faster, and all that parched, overheated vegetation basically turns into pure kindling. The longer it goes without raining, and the hotter it gets outside, the higher the chances of a fire starting, and the faster the flames end up sweeping through the fields and forests in the area. This is already turning into a growing trend for the Mediterranean basin rather than just a one-off event, since every scorching summer leaves behind massive burned-out areas and drains the underground water supply. The ecosystem has a harder time bouncing back from the hit every single time, and the whole recovery process ends up taking longer and longer. A specific factor comes into play, exactly where the majority of the population is concentrated, namely in urban areas. Asphalt surfaces, concrete structures, and building roofs absorb solar heat during the day, and at night they gradually release it back into the environment. So city environments cool down much more slowly than the open countryside outside the city limits. Add humidity to the mix, and when it reaches high levels, sweating loses its effectiveness, meaning the body cannot cool down even during the night. The exact same temperature under these conditions poses a greater physical danger than it would in a dry climate, especially for older adults. Heat in an urban environment and heat out in the open with the exact same thermometer readings represent 2 completely different levels of stress on the human body. In the city, a person experiences a double whammy: the heat trapped by surfaces throughout the day, and the humid air that prevents the body from cooling off. All of these processes are interconnected, and to really see that, you need to take a step back from isolated events. The year 2024 turned out to be the warmest year on record for the entire planet. The average annual temperature crossed the 1.5 degree mark compared to pre-industrial times. the exact threshold that experts have been flagging as critical for decades. This means that the entire climate system as a whole has built up an excessive amount of heat, rather than just some specific region or time of year. Right around the same time, there was a sharp spike in ocean water temperatures that coincided with the warming of the air. And this overlap of two events had a real underlying cause. The high temperatures over the continents, marine heat waves, and how the human body reacts to all of this are all parts of a single mechanism with the exact same source. Oceans are not directly connected to each other, but changes in one spot affect another through the movement of air masses and ocean currents. This is how energy spreads across the entire planet, and scientists call these distant connections between remote regions teleconnections. A number of models indicate that the rising temperatures in the North Atlantic might have altered the circulation of air masses and affected the trade winds in the Pacific Ocean, which are a key factor in shaping El Niño and its overall strength. Right now, this remains just an assumption rather than an established fact. According to some models, the anomaly in the Atlantic could have acted as one of the triggers that pushed the system toward a phenomenon the press called a super El Niño, even though such a category is not officially recognized in scientific terminology. This represents the next major piece in the overall chain of events. El Niño is often described in simple terms as a rise in temperature in the Pacific Ocean. But that is the equivalent of defining a hurricane simply as wind. In reality, there is a simultaneous change in the entire system of winds and rainfall in the tropical zone of the ocean, not just the warming of the water. Trade winds shift their direction and intensity. Rainfall zones move around, and heat transfers between the ocean surface and the atmosphere. The impacts are felt way beyond the Pacific Ocean, showing up as droughts in some areas, floods in others, and freak heat waves or cold spells in places that normally never see them. Over the past 50 years, a few El Niño events have gone down as exceptionally strong, specifically the years 1982 and 1983, 1997 and 1998, along with 2015 and 2016. Each one of them showed just how massively the fallout can spread across the entire planet. The first of these events caught everyone completely off guard. The monitoring systems of that time missed it, failing to spot it in time, and the whole world felt the effects. The second episode was considered the most powerful one on record for a long time, and that is exactly when the name Super El Niño really stuck. The third episode practically tied that exact record in a bunch of ways, and in some aspects, it even blew right past it. El Niño acts as more than just some regional fluke in the Pacific Ocean. It works like a global switch that changes how air masses move all over the world at the exact same time. Observational data shows a very clear pattern. Powerful El Niño episodes and rising global temperatures go hand in hand year after year. Warm surface waters pump excess heat right into the atmosphere, and that heat spreads across the entire planet, driving up the average temperatures. That is exactly why years with a strong El Niño consistently become the hottest on record for the planet. When long-term warming from greenhouse gases converges with the excess heat from El Niño, both factors push in the same direction at the exact same time. This double whammy had meteorologists worried even before the events of 2023 unfolded in full force. The issue was not the warm phase of the Pacific Ocean itself, but rather the backdrop it played out against at that very moment. The global ocean was already running way too hot by that time, and the convergence of two independent heat sources is not something that happens often. Usually, different climate factors cancel each other out, at least a little bit. But that time around, both of them were working in the exact same direction. The National Weather Service and meteorologists from international organizations warned about this exact combination of factors well in advance. When heat from the Pacific Ocean gets added on top of an already warmed ocean, the total effect ends up being way stronger than if each factor was acting all by itself. A situation where such a massive warm phase coincided with such an overheated global ocean had simply never happened before. The warm phase in the Pacific Ocean has a specific quirk that people often overlook. It does not just stop abruptly and instantly. The effects linger for months after its intensity begins to drop, because the ocean and atmosphere transfer stored heat back and forth with a delay. By the time the data shows the anomaly weakening, the planet technically has not fully cooled down yet. Some of the stored heat has already left the atmosphere, some has spread through ocean currents, and the system is still reacting to an impulse that is already losing steam according to the measurements. Based on a number of calculations, the warm phase added a few tenths of a degree to the global temperature on top of the usual increase. The end of the warm phase does not guarantee that everything will instantly return to normal on its own. Temperature records could keep being broken for a long time after the shift in the Pacific Ocean moves into a neutral or even cold stage of its cycle. The fallout is visible not just on temperature gauges, but also in the daily lives of fishermen, farmers, and energy workers all over the globe. Warmer water does not hold dissolved oxygen as well, which is a long-established chemical fact, but its impact on marine life has turned out to be much worse than predicted. When oxygen levels in the upper layers of the water drop, a normal habitat turns into an unlivable space for fish. They migrate to cooler zones rich in oxygen. And this happens all at once, in countless spots around the planet, rather than just locally. Fishing grounds that have fed entire regions for centuries are yielding smaller catches year after year. This takes a direct toll on the people and local economies in areas where fish has always been a dietary staple, and food prices there are spiking noticeably as a result. At the same time, the energy sector is undergoing a major shift, driven by that exact same delayed effect of trapped heat. When extreme heat hits, the demand for electricity to run cooling systems skyrockets, and the power grid is often completely unprepared for the load, especially in places that rarely used to see these kinds of heat waves. On top of that, power generation itself becomes less efficient, as droughts drain water reservoirs and cause hydroelectric plants to lose their generating capacity right at the moment of peak demand. Wind patterns are also shifting, and wind turbines start producing less power exactly when consumers need it the absolute most. This single phenomenon is simultaneously driving up energy demands and crippling our ability to produce it across different parts of the globe. We are not just looking at an isolated glitch, but rather a clear pattern that is intensifying right before our eyes and repeating itself with greater frequency every single year. Events that used to happen only once every 10 years have now become almost annual occurrences, and each new one is no longer viewed as an exception, but rather as just another episode in a long, ongoing series. Stretches of extreme heat drag on for weeks, leaving absolutely no time to recover before the next wave hits. The focus has shifted, and it is no longer about overcoming something extraordinary, but about living in conditions where such things become the norm for entire regions. For a long time, every anomaly was viewed in isolation, as if it had no connection to the rest. High temperatures in one part of the world, a lack of rainfall in another, unusual rain patterns in a third, and on the surface, it seemed like these events were not intertwined at all. Climate studies over recent years have pieced together these scattered facts and revealed the connection between them. These cases were not labeled as identical, but they were included in a broader system. And this transformed the very nature of how the situation is discussed in both the scientific community and the public sphere. The line between understanding and ignorance does not lie in the ability to accurately predict the weather for tomorrow or prevent the arrival of a heat wave. It is drawn right where people start realizing there is a systematic process at play instead of a bunch of random coincidences. And the surprise at each new manifestation ends. In reality, this means that cities are obligated to cope with heat waves that were previously considered rare, utilizing indoor cooling, reserve power grid capacities, and sufficient water resources. For coastal regions with a developed fishing industry, it makes sense to plan changes in fishing grounds well in advance, rather than taking action only after losses have already been incurred. Agriculture in arid zones, such as the Mediterranean, needs to be re-evaluated with the expectation of longer periods without rain and an increase in wildfires for many years to come. Preparations must be made not for a single anomaly, but for them to become more frequent and severe, since the accumulated heat does not just dissipate at the end of one season. Understanding the nature of the ongoing changes does not eliminate their consequences, but it does pave the way for proactive measures instead of attempts to make up for what has already happened.